we have here a set of linear equations. Are linear because the highest powers are 1, and we have 3 equations with 3 unknowns. And to solve these, we're going to use here a system which was thought up by Carl Gauss, a German mathematician. It's called Gaussian elimination. Basically, the whole concept is to make those terms equal to 0 by combining the equations together, adding and subtracting multiples of each of these equations to get rid of the term in x there, then the term in x there, and then the term in y there. So given that our result will have a 0, 0, 0 in those spots, we can simply solve for z using the third equation here. Then given that we've got a value for z, we can find a value for y, and then given that we've got y and z, we can finally use the first equation to find the value for x. So we'll call these equations 1, 2 and 3, and we're going to combine them. Now equation 1 is fine as it is, so we'll just leave the x plus 4y plus 6z equals 2. Now we haven't altered equation 1, so we'll leave it just as equation 1. And it's good to be able to communicate out here on the left exactly what you're doing to actually how you're combining the equations, each line by line. So if we want to get rid of that 2x, we're going to use equation 1 or a multiple of that combined with equation 2 to come up with a new equation 2. And if we want to get rid of the 2x here and make that equal to 0, if we just multiply equation 1 by 2, right through by 2, and then subtract it away from equation 2, that will make that equal to 0. So we're going to have equation 2 minus 2 times equation 1. And away we go. So there are lots and lots of little calculations here. It only takes one little calculation to get wrong and the whole thing gets wrong. So you need to be really careful when you're doing the multiplication. So equation 2 minus 2 lots of that. So that'll be 2x, away from that will be 0. And then you've got 9y minus 2 lots of that will be just y. And then you've got 8z minus 2 lots of that. So 2 lots of that will be 12z. And 8z minus 12z will be minus 4z equals, and then this will be 8 minus 2 lots of that will be 0. Now, because we have altered this, we'll call that 2a. We haven't altered equation 1, so we just call it equation 1. Now, likewise, we want to get rid of this 3x in equation 3, and we're going to use a multiple of equation 1, so it'll be equation 3 minus 3 times equation 1. And you've got 3x minus 3x is 0. You've got 17 minus 3 lots of that, that's 12y. So you've got 17y minus 12y, so it'll be plus 5y. And then you've got 5z minus 18z, which will give us minus 13z. And you've got 13 minus 3 lots, that's 6, so that'll be equal to 7. So we'll call that 3a. Now our next step is to get rid of the 5y here, and we'll just use equation 2a, a multiple of that combined with that. So equation 1 hasn't changed, so we've got x plus 4y plus 6z equals 2. That's still equation 1. And equation 2, a, can just be written without the 0, and we've got y minus 4z equals 0, so that's 2a. Now, we want to get rid of this 5y, so we will just go equation 3a minus 5 lots of 2a. So here's our 2a. I'm going to multiply it by 5 and subtract it from 3a. So that'll be 5y from 5y is 0. And then we've got minus 13z, take away 5, take away 5 times this. Now 5 times that is negative 20z, and a minus becomes a plus. So you've got negative 13z plus 20z, so that'll be plus 7z is equal to, and it'll be 7 minus 5 zeros are 0, so 7 minus 0 will be just equal to 7. Now because we have altered 3a, it'll become 3b. Okay, we've got 3 equations we can simply solve now by firstly solving for z. So you've got 7z equals 7, and that just gives z equals 1. And we substitute for that value of z back into there, and we get y minus 4 times 1, which is 4, equals 0. So that will give us y will be a value of 4. And then we're going to use the y and z way back in equation 1. So we've got x plus 4y. 4y is 16, plus 6z is 6, equals 2. And you have got x is equal to, so that will be 22, so it'll be 2 minus 22, which will be equal to negative 20. So we've got x equals negative 20, y equals 4, z equals 1. And it's most important that when you do these, that you actually check your answers by going right back to the original equations and substituting those values to make sure we're true. So let's use these values. So equation 1 is x plus 4y plus 6z equals 2. So the left-hand side of that equation would be equal to negative 20 plus 4y, so that's 16, plus 6z, which will be 6, and 16 plus 6 is 22 minus 20 will be equal to 2, which is equal to the right-hand side. So the first equation is true with those values. So the second equation is 2x plus 9y. These are the original equations. If you're asked to solve, equals 4. So the left-hand side of that equation becomes, when I put those values in, 2 times negative 20, so that'll be negative 40, plus 9y, so plus 36, 9 4 is 36, plus 8 times 1 plus 8, and what's that equal to? So that's equal to negative 4, negative 4 plus 8 is equal to 4, and yes, that's equal to the right-hand side, so that is true. And then the final equation would be 3x plus 17y plus 5z equals 13. So the left-hand side of that one is equal to 3x's, negative 60, plus 17 times 4 is plus 68, and then plus 5z is plus 5. So negative 60 plus 68 is just 8, plus 5 is 13, equals the right-hand side. So the check is most important, that you make sure that the 3 values you got for x, y and z satisfy the original equations. So just quickly going over it again, Gaussian elimination, when you've got a linear set of equations, if you've got 4, the triangle would be a little bit bigger, so you eliminate the first column here underneath there, so we don't worry about the first equation, we just eliminate the x's in the subsequent equations, then the y in the third, and then the z will just stay as it is because that's the last one when we've got 3 unknowns. You then, using that value of z, you can actually find the value of y in the second, and then working back up with that y and that z value, you're able to calculate a value of x.